So any questions on the cell, DNA? Are you convinced that it's too complex for it to happen by chance? All right, cosmology. Before we get into the cosmology, not to be confused with a cosmological argument, can I get maybe Charlie and John and Jonathan up here? You're gonna earn your volunteerism here, or as we said in the Navy, voluntold. Voluntold to go do something. Yeah. All right, so they each have a penny. And if any one of those were to flip a penny, what's the odds that it would come up on heads? Good? Yeah, that's pretty good. Pretty good odds. But mathematically, it's 1 in 2 or 50-50 chance. All right, so what's the odds that if John and Charlie were to both flip at the same time and they were both going to land up on heads? What are those odds? 1 out of 4. So we take 1 over 2. This is where I was wanting to have my pad of paper so I could show you some math here. So it's 1 over 2 times 1 over 2, which if you remember in fractions, you multiply the numerators, multiply the denominators. 1 times 1 is 1. 2 times 2 is 4, right? So it's 1 in 4 chance, right? Because they could both have tails. Charlie could have heads and he could have tails, or that could be swapped, or they could both have heads, right? So there's 1 out of 4 combinations that they would both land up on heads. All right, now as we add another person flipping a coin, what's the odds there?
1 in 6.
Not 1 in 6.
1 in 8. Well,
1 in 8. 1 in 8. Is this going by too fast, Dan?
I'll just enjoy watching them flip.
Okay. All right. So each time we build it, like if it's the same percent here, in this case it's 1 over 2, it's going to be like just 1/2% chance that he would land on heads. Now we add Charlie, it's 1/4% chance that they both land on heads. We add Jonathan, now it's 1/8% chance that all 3 of them would land on heads. If I were to get in here and start flipping, there's 4 of us, it's 1/16, right? Just keep on multiplying that bottom number by 2, okay? So the more people that we had up here trying to flip and all land up on heads together, obviously the harder and harder it's going to be, the less likely that event's going to be. All right. If you can deal with that, here's our last level of complexity. Let's say all across America, there are groups of 4 people flipping coins to try to get heads, okay? There's just more than just CHBC, right, doing this today, you think? Or you think we're the only ones? Well, the more people we have doing that, then that's going to actually make it more likely that we can come up with everyone landing on heads. Like the more trials we do, we would think eventually we would all end up on heads, right? Depending on how many people we had. So that's thank you guys. You want to see us all flip and just see? Okay, all right. So we're all going to flip and see if we can land on heads. You ready to reveal? Oh, see. Oh, tails. Whoa! So, yeah, all right. Oh, y'all can keep the penny. That's your payment. That's your payment. So that probability is going to be the mechanism behind our next argument, and it's elements of design from cosmology. The Earth is a privileged planet in the cosmos. It's a very privileged planet. And there are several things that are needed for the Earth to be able to have life, to sustain life. And this is just a short list. There's actually about 25, somewhere between 20 and 30, depending on who you talk to, that they will say are things that have to exist on Earth, or the Earth has to be around in order for Earth to support life. The one is our place in the universe. Where are we at in the universe? If we were towards a cluster of galaxies all giving off X-rays all the time, it would be hard for us to live. We would all, nothing would be able to stay together. Our place in our galaxy, if we were toward the center of our galaxy, or if we were next, and in fact, they'll talk about it, but there's actually a large dust cloud between us and the center of our galaxy that helps block all of the radiation and visible light from the center of our galaxy. Our place in our solar system. If we were very close to our sun, we would have extreme heats. If we were very far from our sun, we'd have extreme cold. In fact, we were in the perfect spot. The size and type of our sun or our star. If we had, a large, massive star putting out, lots and lots of energy, that would be bad. If we had a small, tiny sun that was putting out drops and drops of energy, that would be bad. We have a large moon. Actually, our moon does a lot for us, and scientists are still discovering all the things that the moon does. It helps keep us stable, helps stabilize our wobble, because planets slowly, it's almost like a top. We're spinning like this, and we have a tilt to our axis. Helps stabilize that over, thousands of years. We have a tilt to our axis. Mercury is about perpendicular. It spins about right up and down. Like if this is the moon, here's Mercury. It spins perfectly. And that guy is extremely hot. Of course, he's real close to the sun on one side, extremely cold on the other side. And this causes huge issues because this rock gets superheated and it starts, things get hot, they expand. And then on the other side, things get cold and they contract. So this causes huge issues with Mercury. The planet Uranus is actually on its side. It's spinning like this around the sun. And those two planets' temperatures are all messed up. We have this slight tilt. And it helps produce our seasons, helps keep us all, lets the energy go around. We have a strong magnetic field inside our Earth. Now, does anyone know what the northern lights are? Southern lights. You've seen them? Seen pictures of them? Actually, our sun is producing charged particles called the solar wind, and it's going out everywhere from the sun. Well, our magnetic field blocks almost all of these because it goes around it, and you'll see a picture of this. It goes, the solar wind will go around our Earth, and it protects us from radiation again. Well, the northern lights are just where you've seen like the magnetic field lines of a magnet. Well, that's what happens on our Earth too. Those charged particles get caught in those magnetic fields, and some of them get swirled down to our atmosphere, and that's what causes those aurora borealis or aurora, whatever the southern ones are. Southern Alice, I don't know. Plate tectonics. Energy that's produced from plate tectonics. I didn't read all this one, but for some reason we need plate tectonics too. Well, Jupiter. Have you ever heard of white dwarfs? Black dwarfs? Actually, scientists call Jupiter a brown dwarf. It is a planet that is just too small to become a sun because there's a lot of solar systems that are binary. They have actually two stars in them that rotate around each other. Well, Jupiter just missed that. But it's so massive that it takes all the asteroids for us. So we're thankful for Jupiter by swinging those asteroids and keeping them away from just annihilating the planet all the time. But if we didn't have a very, very, very large, massive planet out there, we would statistically be hit by asteroids more often. An abundance, but not too much oxygen, because life needs oxygen to survive. We use it to break down stuff. Abundance of water. And then if you want more information, you can go to this website, and there's plenty of others out there.